All right, can everybody hear me? All right, perfect. I have started the recording. So this, as you guys know, is the Exam for Prep webinar. So if you could have a calculator, paper, and pencil handy, I may ask you to do a couple of calculations as we go through it, just to make sure that you're comfortable with the material that we're covering, okay? All right. So first I'd like to go over a couple of etiquette things. If you guys have been to a webinar this term, I'm sure that you have heard these things before. But during the webinar, please post questions in the chat box. I'll answer them as we go along. I don't want you to wait until the end and then, realize that you forgot to ask a question. And your peers who are watching this recording may benefit from the questions that you have as well. Also, with that being said, please don't have any side conversations in the chat box. Let's keep it webinar focused so that we're not clogging it up. And then last but not least, please post only constructive comments in the chat box. So we don't want to post anything that could potentially, offend one of your peers or, hurt their feelings. We want to make sure that it is constructive and positive, okay? All right. So a couple of test-taking tips. So first thing I recommend is give yourself about 2 hours to answer the 15 questions. This exam is 15 questions long. It may take you more or less time. It's all dependent on you and your test-taking strategy. If you have been taking your exams and it's been taking you 4 hours, give yourself 4 hours. So while you're taking your exam, turn off your TV, turn off your phones, any other distractions. So you don't want to be getting through your exam and then be like, oh, I wonder what's going on Facebook. Focus on your exam, get it done, and, don't allow yourself those distractions because that's when you start to make errors. Third, have your notes, book, and exam review ready and with you. So these are open book exams, as this is the 4th exam. I hope you guys all know that. So you can use your notes, you can use your book, you can use any study questions that you have. Make sure that everything is ready to go so you're not fumbling to find these resources as you're trying to take the exam. And then last but not least, watch your decimal places. I say this to every single student that I work with in one-on-one sessions and study hall sessions. Watch your decimal places because that's where a lot of people trip up. Especially with this exam, it may say round up to the nearest integer or round to 4 decimal places. It can really change from problem to problem, so make sure that you are checking your decimal places. All right, so next let's look at some of the formulas that you're going to be using for this exam. I'm hoping at this point in the term these all look familiar to you if you're getting ready to take your last exam. So the simple interest formula, I equals PRT. I is interest, P is principal, R is the annual interest rate, and T is time in years. The compound interest formula, A equals P times 1 plus I to the n. A is the amount at the end of n periods, so the future value. P is the principal, which is also known as the present value. R is the annual rate. M is the number of compounding periods per year. I equals total number of compounding periods, or rate per compounding period rather, and N is the total number of compounding periods. And we also look at the continuous compound formula. So A equals PE to the RT. So A is future value, P is present value, R is our annual rate, and T is time in years. Is everybody fairly comfortable with these 3 formulas at this point? Perfect, that's what I like to hear. All right, and we're also going to look at the future value of an ordinary annuity. So the future value equals payment times 1 plus I to the n minus 1 over I. where FV is our future value, PMT is our payment per period, I is our interest rate per period, and N is our number of payment periods. So one thing to note, especially if you're using Excel to do your calculations, is that all payments for our problems are made at the end of the period. Okay? And then the present value of an ordinary annuity. So this is PV equals PMT times 1 minus 1 plus I to the negative N over I. PV is our present value, PMT is our payment, I is our interest rate per period, and N is our number of payments. So again, payments are made at the end of each period. Is everybody comfortable with these formulas as well? They've worked with them? All right. So, has everybody had a chance to take a look at the exam guide for this exam coming up? Okay, so that's what we're going to go over. As you are getting ready to take your exam, I would recommend looking at it. It should be in your Blackboard classroom, but once we're done with the PowerPoint, I can upload it right into here, into the Connect Classroom, so that everybody can have a copy of it, so that they can look at it before the exam. So what it is it breaks down the problems that are going to be on the exam. As I mentioned, this one's going to be 15 problems. It tells you the concept, related problems, and any notes. So, for example, number 1, we are looking at using the simple interest formula to solve for the missing quantity. Similar problems to this are Module 7, problems 3, 4, and 5. And they did note to remember to make sure that you use the time T in years. So this is a really helpful guide as you're going through and doing your exam, if you ever, need to go back and reference any of these problems, okay? So let's take a look at an example. So numbers 1 and 2, very basic. So we are going to use the formula for simple interest and given values to find the missing value. So we have I equals $72, R is 6%, T is 6 months, and P is what we're looking for. Now, can you guys tell me what we're going to be using for T when we go to put it into the formula, if it gives us 6 months? Correct, 0.5. 6 months is half a year. So we put our variables in. This one, we were bad when we didn't simplify the fractions 6 months out of 12. Don't hold it against me. So once we go in, we have 72 equals P times 0.06 times 0.5, which ultimately is 72 equals P times 0.03, because 0.06 times 0.5 is 0.03. We divide both sides by 0.03, and that gives us a value of P of $2,400. Okay? All right, so let's look at one more problem. So again, we're going to use the simple interest formula and the given values to find the missing value. So I is $24, P is $1,600, T is 90 days, and R is unknown. So there's our simple interest formula. Now, can anybody tell me how many days are in the financial calendar? How many days are we going to take this out of? Perfect. You guys are awesome. 360 days are in the financial calendar. That's true for this class as well as accounting classes. I don't know if you guys have to take accounting classes, but they also use a 360-day calendar. So we go in and we put our numbers into our variables. So we have 24 equals 1600 times r times 90 over 360. 90 over 360 in decimal form is 0.4. We do the math, which gives us 24 equals 400 times r. We get rid of that by dividing both sides by 400, which gives us 0.06 is r, which is 6% for our rate. Does anybody have questions on the simple interest formula before we move on? I'm going to take the silence in the chat box as a no. Alright, so let's take a look at numbers 3 and 4. So this is using the compound interest formula. So in the homework, it's module 7, problems 9, 10, and 11 for problem 3, 9, 10, 11, and 12 for problem 4. So the notes that they give you is to enter module 7 in review mode and go to problems 9 through 11. View an example if you want to practice. Okay? So let's take a look at some examples. So first, use the compound interest formula to find the missing value. So we have P equals 2500, I equals 0.079, N is 23, and we're looking for A. And this is our compound interest formula. So we have A equals P times 1 plus I to the n. Is everybody familiar with what that little caret means? Perfect. So let's go ahead and we'll put in our variables. This one we're looking for A, so it's extremely straightforward. So we have 2500 times 1 plus 0.079 to the 23rd. 1.079 to the 23rd is about 5.74768856. Another thing that I do mention all my students is wait to round until the very last step, if at all possible. In this particular one, the answer was even longer than this. So I rounded it out to enough decimal places that it wouldn't affect my answer. So go out as many decimal places as you're comfortable with. I normally recommend no less than 6. Okay? So then we do 2500 times our 5.74768856. And that gives us a future value of $14,392.22. All right? Perfect. Now, if anyone finds an interest rate that is 7.9% that they're giving me back, not that they're charging me, give me a call. All right. So let's look at example B. So again, we're going to use the compound interest formula to find the missing value. So in this one, A equals 9,600, so 9,600. I is 0.069, and our number of compounding periods is 93, and we're looking for P. So we put our variables into our formula. And then we do some of the math. So can you guys tell me what 1 plus 0.069 to the 93rd power is? If you could round it to 5 decimal places, that would be great. Audrey, you do not have the correct answer. Yep, you guys are correct with 495.36644. Oh, you used 23. That'll do it. All right. Good job, guys. So that gives us 9,600 equals P times 495.36644. Hey, no worries about it, Audrey. We all have those days, I promise. Especially as it's coming to the end of the term. All right, so what we're going to do is we're going to divide both sides by 495.36644 to get P alone, which gives us a value of P of $19.38. Okay? All right, so let's look at some application problems for number 3 and 4. So the first example, if $17,000 is invested at 4% compounded quarterly, what is the amount after 10 years? So the first thing we need to do is we need to find I and N. So I, our interest rate per period, is our annual interest rate divided by our compounding periods per year. So that's 0.04, which is our interest rate, divided by 4 periods per year, because it's quarterly, gives us I of 0.01. And we take the number of compounding periods per year and we multiply it by the time in years. So we have 4 periods per year times 10 years gives us 40 compounding periods. We use our compound interest formula. We put our numbers in. So 17,000 times 1 plus 0.01 to the 40th power gives us a future value of $25,310.68. In example B, if an investment company pays 3% compounded semi-annually, and you want to have $20,000 in the future, how much should you deposit now to have that amount in 5 years? So again, we find I and N. So our annual interest rate is 0.03. There's 2 compounding periods per year because it's semi-annually, which gives us the value for I of 0.015. N is 2 periods per year times 5 years gives us 10 for our total number of compounding periods. Again, we have our formula, but this time because we know our future value and we're looking for how much we need to deposit now, we're looking for P. So when we put our variables in, we have $20,000 equals P times 1 plus 0.015 to the 10th power, which calculates out to be 1.160541. So then we divide both sides by that value. So $20,000 divided by 1.160541 gives us a present value of $17,233.34. So if we were to deposit $17,233.34 right now into an investment account that pays 3% compounded semi-annually, in 5 years we would have $20,000. All right. Let's take a look at numbers 5, 6, and 7. So 5, 6, and 7 use the continuous compound interest formula. So for these problems, number 5 is similar to number 17. Number 6 is module 7, number 17 and 18. And number 7 is module 7, problem 14. Okay? So one of the tips that it does give you in here is if you're not using a TI 83 or 84 calculator, to use an online scientific calculator. Or make sure that you're using a scientific calculator with the E button. Okay? So does everybody know of, what scientific calculator that they want to use? Does everyone have a ultra reliable calculator? Perfect. Web 2.0 Calc is a great one. Desmond's is a great one. There's actually even a fairly great scientific calculator built into Microsoft Windows. The one that I actually use is from the accessories folder in my programs. If you go to View, you can change it to Scientific, and that works well as well. Alright, so let's look at an example. So use a continuous compound interest formula to find the indicated value. So A equals 15,875, P is 12,100, T is 48 months, and we're looking for the rate. Now I know you guys are so excited to do this one because we're going to be using the natural logarithm. So we use the formula A equals PE to the RT. So what we do is we put our variables in. So we have 15,875 equals 12,100 times e to the 4 times r. So the first thing we do is we get rid of that 12,100. We divide both sides by 12,100. That gives us 1.311983 equals e to the 4r. Okay? Now to get rid of that e, to drop down that exponent, we find the natural logarithm of both sides. So we find the natural logarithm of 1.311983, and that equals 4r times the natural logarithm of e, which essentially cancels that out. So we have the natural logarithm of 1.311983 equals 4r. So we divide both sides by 4. So the natural logarithm of 1.311983 divided by 4 is our value of r. So can you guys, using those scientific calculators that you're planning on using, tell me what our answer is going to be? What is going to be our value of r? All right, let me go back. Sorry guys, I don't know what happened. Can you guys hear me now? All right, I'm so sorry about that. So we're going to take a look at the application problem. I don't know if you guys kind of followed along as I clicked through the slides, and for some reason my mic got muted. So if the population in a particular country is growing at 1.7% compounded continuously, how long will it take for the population to double, round up if not exact? So we're looking for a set number of years, full years. So we have the formula A equals PE to the RT. 2 is going to be A because we want it to double. P is 1, so it was eliminated in this step because 1 times e to the RT is e to the RT. So 2 equals e to the 0.017 t. So we find the natural logarithm to drop down that exponent. So the natural logarithm of 2 equals 0.017 t times ln of e, which is 1, which gives us the natural logarithm of 2 equals 0.017 t. We divide both sides by 0.017 to find t. So can you guys tell me how many years it's going to take for our population to double? Remember, round up if it's not exact. Perfect. 41 years. Great job, guys. All right. So numbers 8 and 9, we are going to compute the rate per period and the number of periods for the future value of an annuity. So you guys should be pros at this, I hope. So this is Module 8, Problem 1. Both of them are very similar problems. Both are just like Problem 1 in Module 8. So let's take a look at an example. So quarterly deposits of $500 are made for 12 years into an annuity that pays 8% compounded quarterly. Find I, the rate per period, and N, the number of payments. So I equals R over M. Our rate is 0.08. There's 4 compounding periods per year because it's quarterly, so that gives us I equals 0.02. And then N, 4 payments here for 20 years, so 4 times 20 equals 80 total payments. All right? Has everybody got this down? You guys made it all the way through Module 7 and 8, so I hope so. All right. And we are officially halfway through the exam. We're more than halfway through. We've only got 5 problems left. How are you guys feeling going into this exam so far? Okay. What is it that you don't understand about the logarithms? How to calculate it? Like how to use the button in your scientific calculator? Alright. Let's say after the recording has ended, and I can go through that a little bit more with you, okay? Alright. So, let's take a look at numbers 10, 11, and 12. So, this is the formula for future value of an annuity. So, this is like Module 8 Problem 2, Module 8 Problem 4, and Module 8 Problem 6. So, let's take a look at an example. So, use the future value formula to find each of the indicated values. So, the first one's going to be pretty basic. N is 20, I equals 0.03, our payment is $500. What is our future value? So this is our future value formula. So the first thing we do is we go and we put in our known variables. In this one, because we're looking for the future value, it's pretty straightforward. So 500 times 1 plus 0.03 to the 20th power minus 1 divided by 0.03. If you do the math in the parentheses, that gives us 500 times 1.03 to the 20th minus 1 divided by 0.03. So if we do that work on the right, so 1.03 to the 20th minus 1 over 0.03, that gives us approximately 26.8703744489. So we multiply that by 500, and that gives us a future value of $13,435.19. Okay? Alright, let's take a look at another example. This is more of an application-based problem. So in order to accumulate enough money for a down payment on a house, a couple deposits $300 per month into an account, paying 6% compounded monthly. If the payments are made at the end of each period, how much money will be in the account after 5 years? So this is our formula that we're going to use. So can somebody tell me what we're going to be using for I, if it's 6% compounded monthly? Alright, so looks like, Jamie, you were just a little bit off. It's 0.005 because it's 0.06 divided by 12. Alright, and can you guys tell me what we're going to use for N, how many compounding periods there are? That's how many annual compounding periods there are, Audrey. How many total compounding periods are there? 60 is correct. So we put that information into our formula. So 300 times 1 plus 0.005 to the 60th minus 1 divided by 0.005. So can you guys tell me how much money we'll have in our account after 5 years? Let's see, Audrey has $20,931.01. I see Gretchen typing, and they match. Great job, guys. Yay! All right, let's take a look at another example. So, use the future value formula for an ordinary annuity to find the indicated values. So this one, we're looking for N. So we have our future value of $4,000. I equals 0.02. Our payment is $200, and let's find N. So this is our formula, as you guys well know and love at this point. So we put our numbers in. So we have 4,000 equals 200 times 1 plus 0.02 to the n minus 1 divided by 0.02. First things first, let's multiply both sides by 0.02. That gets rid of that fraction. So that gives 4,000 times 0.02 is 80. This leaves us with 80 equals 200 times 1 plus 0.02 to the n minus 1. Next, let's divide both sides by 200 to get rid of that. So 80 divided by 200 is 0.4. So we have 0.4 equals 1 plus 0.02 to the n minus 1. If we add 1 to both sides, that gives us 1.4 equals 1 plus 0.02 to the n. Which 1 plus 0.02 is 1.02. So we then find the natural logarithm of both sides. This is to drop down that exponent. So that gives us the ln 1.4 equals n times ln 1.02. Now remember, because we're not using e, it doesn't equal 1, so it doesn't cancel out. So to get n alone, we divide both sides by the natural logarithm of 1.02. So the natural logarithm of 1.4 divided by the natural logarithm of 1.02 is n. So can you guys tell me what n is in years? And Marie, you had that right on top of it. So 17. That's what I figured. The 4 is right in between the 1 and the 7. So I just figured it was probably too quick. All right. Everybody ready to see the last couple of questions? Here it is, the very last slide for the very last questions. So, question 13 on the exam is just like Module 8, question 15. And then 14 and 15 is similar to 6 and 7. So let's take a look at an example. So eLoan, an online lending service, recently offered 36-month auto loans at 7.56% compounded monthly to applicants with good credit ratings. If you have a good credit rating and can afford monthly payments of $350, how much can you borrow from eLoans? What is the total interest that you will pay for this loan? So, we have our formula. PV, our present value, is our payment times 1 minus 1 plus I to the negative n divided by I. Now, it's important to note that that is negative n, because that's where I see a lot of mistakes come up, is they're just using n as their exponent. So we plug in our variables. So we can afford $350 as our payment, and then 1 minus 1 plus 0.0036. That is our interest rate per period. So 7.56% divided by 12 because it's compounded monthly. To the negative 36 because there's going to be 36 total payments, divided by 0.0063. So can anybody tell me how much we can borrow from e-loans? And Gretchen, if you'd like the slides, I can email you the PowerPoint at the end of the presentation if you want to give me your email address. All right. Has anyone been able to find what our present value is going to be, how much we can take out? You guys are both correct. Audrey, what is it that you're getting for a negative answer? Is the correct amount just negative? Interesting. Let's see if I can figure out how you did that. I wonder if you accidentally hit the negative key somewhere along the lines. becomes negative when you subtract the 1. You're not, in this particular problem, you're not supposed to subtract a 1. You're supposed to subtract from 1. Let's see. Yep, so Audrey, I just went through, I did the calculation. Because you're subtracting 1 instead of subtracting from 1, that's what makes it negative. The same answer, just negative. Yeah, if that happens, you can make it positive when you complete the formula, as long as it's the correct answer, just negative. All right, so what questions do you guys have for me? Yep, if you guys want me to email you the PowerPoint, type your email into the chat box and I will get that out right after the webinar.